Welcome, everyone. Thanks for being here. This is Ginger Bandine, Director of Clinical Data and Analytics at Pinnacle Health Informatics, and I'm pleased to introduce our presenter today, which is Shawn Frasier, who is one of the founders of Pinnacle Health Informatics, and he's going to be talking to us today about monitoring your SQL system performance using Power BI. So without further ado, I will let you take it away, Shawn.
Well, thank you, Ginger. It's a pleasure to be here today, and welcome everyone to our webinar. Today's presentation is based on a case study that we did recently and using some interesting tools that I wanted to share with our user community. It's an interesting way to monitor SQL Server performance, and I wanted to walk through this. There's some freeware tools out there that are useful and handy, and somebody may find this useful in their practice of database administration. So today we're going to talk about some tools that are free and easy to use. The first tool that we're going to talk about a little bit is Power BI Desktop. That is a free download. They do have higher levels of paid service, but you can download the Power BI tool and use data and build dashboards and use it for small projects at no charge. And you can get that at Power BI. I've included that in this slide here. We're going to look at some dashboards that were built for monitoring SQL Server performance. This is also a good introduction to those metrics. So we're going to talk about some metrics that may or may not be familiar to some people. And it's also a good introduction to Power BI because there's some pre-built content here that people can download. Now this is not my original content. There is a fellow on the internet that's somewhat well known for SQL and SQL performance issues, and his URL is there. His name is Brent Ozar, and these are his, and so we're going to be showing some of their content. He gives this away freely, and you can visit that URL there, and you can get these Power BI dashboards. But we'll be looking at an implementation today of these. So let's look at our case study today. We have a data warehouse server. Pinnacle does a lot of data warehousing. We have a lot of customers with various installations of the data warehouse. We have various flavors. We have some that hook to and connect with CCP, which is based on Microsoft Dynamics, with a package called Profiler, which is a electronic medical record software that's been around for some time. We also work with Credible and with Avatar, which is from a company called NetSmart. This particular company, which we'll call Acme Behavioral Health, was running slowly. A lot of complaints and concern from this client. The data warehouse build was taking 10 hours or more, which is very unusual, and that's a source of concern. So what we were thinking, there's something not quite right with this server at some level. Report response reported as slow, so people running dashboards and reports, they were saying that the response was not up to speed. The OLAP cubes, OLAP cube is a special database that we build that allows for drag and drop queries. Those were building slow. Overall system sluggishness. Now, the one thing that was on this system that was a concern for me is everything was run off a network attached storage system that ran over iSCSI. So that utilizes your network infrastructure to transmit SCSI signals back and forth from a hardware array, so a disk array. Now, I'm not saying that's a bad way to do it, and I'm sure there's very, 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 very fast iSCSI systems, but this one in particular seemed to have an iSCSI disk subsystem that concerned me. So I wanted to focus on that a little bit. Okay, so we installed the Power BI dashboard process, and it consists of a couple of stored procedures. I have those running every 15 minutes. They read data management views, so they're very, very low impact on the system. It inserts data into database tables, at 15-minute increments. And then these tables I have set to truncate every Monday early in the morning so that you don't get too much data. And then, you get a new weekly picture of the performance of your database. So this can just run in the background, and then you can monitor through the Power BI dashboards. Okay, so let's get into this here a little bit. So this is what the front of the dashboard looks like. Okay, and we will actually attach to a live system here shortly, but this is a screenshot. You can see here that you have some date ranges, and we're looking at batch requests per second. And these are all dealing with SQL metrics. How busy is the SQL server? How many processes are going through the processor? How many calculations is it performing? We're looking at all of these metrics here: buffer latch, CPU, idle time, memory, various things over time, and so we can get a sense of how things are performing. Then over here on the right, we have some of these weight types, right? And these weight types were concerning me a little bit, just because the system seemed to just be so slow in performing. And we look at the top, they're a little bit cryptic. I'm going to talk about a few of these. There's a CX packet, asynchronous network I/O, and whatnot. So that's kind of what the dashboard looks like overall. I'm going to look at some specific views here. So this is that top right-hand view, and we're going to look at some of these weight statistics. Now these are in minutes, and they look very long, and it's my thought that because these are, you have thousands of processes running in parallel, and it's adding up all that wait time, that you would get these large numbers. So we can see that some of these are we're getting values back 194,000 minutes on CX packet wait time. Now CX packet deals with parallel execution in a CPU, and these get a little geeky and a little technical, but what I want to show is that we had some baseline we could capture, right? We don't worry too much about what these numbers mean, and specifically we can get into that a little bit, but basically is the system performing well? And at this point, I really didn't know. These numbers look a little high to me, and so it was a source of concern. Things like I/O completion, 3,000 minutes of wait time. That does sound like things aren't getting through the system. So that's one view. We can look at these over the course of the last several days. And so on this source system, I took all these statistics and I captured all these statistics prior to any remediation that we did on this server. Okay. So this is another screen. So we see here that this is another section of the dashboard. We're looking at batch requests per second, and you can see, it's almost at 0, and then it boosts way high, and then it drops, and then it's really low, and then it drops down. And when it drops to less than 0, what that means is you have processor cores that are not doing anything, and apparently it registers kind of negative values, that they're so idle. And this isn't very good. I mean, you don't want to have, what this appeared to me is that we have a CPU that's not doing anything because the disks are not delivering the data in a timely fashion to the CPU for processing. And that was my impression here, looking at this chart. Another section of that Power BI dashboard is this section here, and these are some details. It has a resource intensive query on the bottom, and then on the top section it has kind of a summary for each time the stored procedure runs. And you can see here there's a lot of problems. Your server is experiencing write log waits here on the second line due to slow log file writes. This is one of the reasons why. And if you click on that, you can get details. We'll look at a live system here, and we can look at the details of that. But you can see, there's all kinds of problems with this server, right? There's all kinds of wait time problems. And so these dashboards allow you to kind of get in there and take a look. and see what's going on, some of the details. So we can see here that there's something certainly not going on, or not healthy on this server, and we're concerned about it. Okay, so some of our findings, according to the Microsoft specification, we had long write log wait times due to poor disk performance, greater than 2,500 minutes. We had long CX packet waits, longer than 190,000 minutes, which seems really high in minutes, but again, the Microsoft specification says it's due to just a cumulative effect of thousands and thousands of processes running in parallel. Async network I/O, so this is the amount of data that's getting pulled through the network subsystem at greater than 5,000 minutes worth of waits during our testing period. I/O completion, that's getting data in and out, processed back to the disk, right? So greater than 3,800 minutes. And then there's this sleep backup pull flush waits is greater than 30. These are about six or seven of the 10 or 12 that's on that dashboard that I just chose to kind of focus on. And we're seeing that sleep B pull flush is it's greater than 3,500 minutes. And that's just another measure of how quick things are getting from the disk through the CPU and then processed and moved on. So that's what we found. So here were the recommendations. So my thought was the disk system is really suffering. So we've got to get it off that iSCSI backbone and put onboard SATA or SAS, 15,000 RPM, 10,000 RPM disks that are attached directly to the server bus, not over the network or anything. So a bunch of changes were done. We put onboard disks in the chassis of the Blade server, and we put enough to give us proper capacity. And we reconfigured the temp DB and the log file to use different volumes and different data channels. We modified the memory usage a little bit. And then we reloaded everything and we turned on the monitor to see what the results would be. And so I wonder what the result will be. Anyone wonder? Okay, well, let's find out. Okay, well, look at these numbers. Our parallel CX packet number is much, much less. These numbers were much less, much, much less. And we'll go through a summary here and we'll see exactly how much less. All of these values were much less. Now, this is an interesting chart because we're looking at the batch requests per second. So rather than just a huge spike, we're seeing lots of requests coming in and out of the CPU. And what that tells me, my opinion of that, is that instead of waiting for a whole bunch of data and waiting, and then processing, we're getting data in and out of the processor. So instead of a peak of 4,000 batch requests per second, we're seeing 40, 50, 60 per second, just nice, steady data in and out of the CPU. There's some other measures here that are similar. Buffer input and output, we're just seeing data come in, go out. Much better, I think, much better results here. We're seeing a disk that's feeding the CPU much more efficiently. And that's what we want to see. I think before, the disks were starving the CPU. We had very low CPU utilization, and now we have just much better input output. So this is the second chart. We're just seeing much better results here. Okay, and then on our quick diagnosis summary, you see is as it runs, we're getting much better messaging. So no problems found, no problems found, no problems found. So just, it says you can go look elsewhere, but from the numerous checks that we're doing, we're seeing no problem. So instead of all these long wait times, we're seeing a message of no problems found. Well, this is good so far. So the summary is we had the write log wait times went from 25,000 minutes to 79. a 98% reduction. CX packet weights went from 190,000 to 2,900, an 85% reduction. Our async network I/O from 5,000 to 283, a 94.34% reduction. I/O completion from greater than 3,800 to 7.7. It's a 99.8% reduction. And then that sleep B-pool flush weights greater than 3,500 to 95.54% reduction. So our data warehouse build went from 10 plus hours to under 2 hours on this system, an 80% reduction. The batch requests per second, like I mentioned, were much lower, but much more steady. So it looked like just a disk subsystem that was doing a good job keeping that CPU busy. No problem found were the majority of the results. And then most importantly, the users reported much better response times and better reporting. So some pretty significant improvements. These surprised me. I didn't think we'd see quite this dramatic a level of improvement, but it's like night and day. I mean, the system really runs night and day better. So it was obviously that disk subsystem in this server. So turned out well, and the customer is much happier, which is what we want to shoot for. We can take a minute and we can look at some of the other functions of the Power BI dashboard, and we'll do that in a second on a live system. This is something you could use on any SQL server. It doesn't have to be a data warehouse server. I'd recommend it on any server. I mean, I think these stats are great. It's good for kind of a before and after if you decide to upgrade a server or make changes, add memory, add processors, especially if you've been, if you've had budget allocated to something. It's nice to say, hey, you got a much larger bang for your dollar, because we can monitor before and after. We'd be happy to help. These are easy to set up. You probably don't need any assistance, but if you would like some, we're happy to assist with that. And as always, you can follow us on LinkedIn and Twitter at our website. So those are some of our summary findings. I wanted to jump over, if I could, really quick, and I'll show you this on a live system. Okay. Okay, this is on a live system, and you can see here, this is that chart we looked at earlier, and here are our metrics. And this dashboard, amazingly, I think it captures every single SQL-related performance monitor metric from the data management views, and then it ranks them from greatest to least. Okay, and again, you can click on these and you can look at detail for each query or for each run. If you click on one of those, and it refreshes that top chart, and you can look for each run. The whole chart refreshes. You can look at every one of your metrics. Now, you can also, let's see, let's get this back here. Let's clear that. Here we go, we're gonna refresh these. You can look at your resource intensive queries, so you can right click on any of these and then drill through into the query details. So here we can see one of our intensive queries, which is, what's this one gonna do? This one is, it looks like we're building some of our UDDs, and you can see the query on the upper line here. You can see what was running. Anyway, you can look at some of your query details for any of the queries on this front page in a nice drill through fashion. See if I can drill through that one. Okay, so this one's insert into fact recorded service. So that's one that's going to be building our data warehouse, and you can see here, because it runs nightly, it's going to keep the same statistics. But I guess if we look down here, we can probably see some changes in these over time. Anyway, we can see how much memory is being used. It's kind of interesting. We can look at latency, data latency for the various databases. These are called read quantity and stalls. These are kind of a measure of how quickly data is getting in and out. This data looks pretty good. Pretty low latency on this server. You can monitor database growth. So the data warehouse kind of stays about the same, it looks like, on this system over time. There's a little bit of growth. There's some auto growth that comes on periodically. You can monitor that. We can look at again, we can look specifically at any performance monitor metric here or multiple. We can look at transactions per second total, or we can look at transactions per second from the data warehouse, for example. You can see how that's running, and you can see over time. Looks like there's some idle times. We probably have some times where there's nothing happening, and so we drop down into the negative a little bit, but mostly during the day, it looks like we were running at about, between 55 and 30 transactions every time it's being run. Any wait state anomalies, and these are ones that you can get very in depth as far as detail goes, and you can look at your database and see if there's anything that's a problem. Again, this looks pretty good. It looks a lot better. I don't have screenshots of the previous system. I should have probably taken some of those, but these look much better. And these are performance monitor anomalies. Again, you can look to see if anything is going on that's amiss on your system. So a nice set of dashboards. It gives you a nice overview of your system, cues you into any problems that might be occurring, and it's a great way to do kind of a before and after examination. And in this situation, it worked out really well. So it was, exactly what we needed to do. We prescribed a remediation course, and the server is running much better. So it's just like night and day, which for us is fantastic. We want the users happy, and we want data moving in and out, and reports and ad hoc queries and everything running very quickly and successfully. So with that, I just wanted to conclude and thank everybody for their time today, and please let us know if there's any questions. I do have a question here. It says, was the bulk of the improvement because of the hardware reconfiguration of the log file? I think it was the hardware, 100%. I did very minor tweaking on the log files, other than moving them a little bit and allocating space. I think this was 100% getting off the iSCSI environment. This particular client is ordering, and it's been delivered a really new snazzy, really fast, quote unquote, new iSCSI NAS, but I just don't know how you'd move data through an Ethernet network as fast as you could move it across the bus of the motherboard. Well, and that's a good point. I probably should have only done one change, and then done successive changes, but based on what I've seen, I'm pretty confident it was the hardware. Well, and there's another comment that says the hardest part of performance monitoring is to take the time to monitor and learn the baseline before there is a problem. Exactly, and that's why this is a great proactive tool. This is a great proactive tool that you could have on your desktop and just run every day, or run all the time. You could just keep it up and running.
All right. Well, thank you so much, Shawn. Thanks, everybody, for being here today. If you need any more information, please feel free to reach out, and we will talk to you all soon. Thanks so much for being here.
Thanks, Ginger.
Okay, thanks, guys.